Good morning, our dear students, our dear postgraduate students. All right, so let's get to the fifth lecture in this series. My own aspect of the course Marine Ecology, MSM 831. This is the fifth lecture and the sixth video. I will beg to stop here as my last lecture. So we want to discuss on this topic of plankton. Plankton. Please, it's not planktons. There's no S. The plankton is already a group word. In fact, someone defined it as a group of drifters. So it's a group word. So we say plankton. All right. So plankton are at the base of the marine food chain. They are very, very, very important. In fact, just as we are going to discuss later, we have the phyto ones. Phyte means plant. So we have the phytoplankton, which are the primary producers, autotrophs, photosynthetic primary producers, and they produce up to 99% of the oxygen you see in the sea. All right, so they're very, very important. Let's discuss this plankton. First of all, let's try and define them. What are plankton? What are plankton? You can write a thesis on it, but let's just give it a brief definition. These are organisms found in water that are unable to propel themselves against a current. They are called drifters. They are unable to propel themselves against a current. So they move wherever the current takes them. That's what gives them the name. Plankton, drifters. Okay, so let's try and classify them. Now, with that definition anyway, you discover that plankton can only be pelagic. What I mean is they can only be floating. They cannot be inside the sediment. Okay, because they just have to flow with the current. They can't propel. They don't have will. They might have will, but they don't have the ability to go wherever they want to go. So let's try and classify them. You want to classify them in three broad categories. The first one is the biological classification. The biological classification. Now, under biological classification, we have this plankton as the ones we call the phytoplankton. Phytoplankton are the autotrophs. They are photosynthetic and they are microscopic. That's why sometimes they are called microphytes. Okay, because they are microscopic. Then you have the zooplankton. Zoo means animal. So the zooplankton are the animal-like plankton. They are consumers. Most times they are primary consumers. But they are not autotrophs. They are not photosynthetic. They don't have the chlorophyll. They don't have the ability to utilize the primary source of energy, the solar energy. So we call them the zooplankton. Then we have the bacterial plankton. The bacterial plankton, just from the word bacteria, they are the bacteria-like plankton. They are the bacteria constituted constituted planting, the bacterial planting. Then we have the viral planting from the word virus. So they are the virus-like planting. So these are the four major classifications. But just as we know, and I know that you know, that we most time concentrate on the two, the phytoplanting and the zooplankton. Okay, so these are the classification based on biology, the biological classification. There's also classification based on the size. Please, I want you to take note here. The classification based on size. So based on that, we have the smallest, the smallest one. Okay, let's start from the biggest or the bigger one. The mesoplankton. The mesoplankton, their range in size is from 0.2 to 20 millimeter. 0.2 to 20 millimeter. And you can attest with me that if something is up to 20 mm, that might not be said to be microscopic. Okay, so that's to tell us that, well, not all planting are microscopic, especially the zooplankton. The viral planting, the bacterial planting, the phytoplanting can be microscopic. Some of the zooplankton also can be microscopic, but some of them can be macroscopic. So you have the mesoplankton. The range in size, please note, is from 0.2 to 20 millimeter. Then the next one are the microplankton. The microplankton is from between 20 millimeter, between 20 to 200 micrometer. Between 20 and 200 micrometer. Between 20 and 200 micrometer. The microplankton. Actually, they are microscopic. Then you have the nanoplankton. Further smaller. The nanoplankton. The nanoplankton, the range in size is between 2 and 20 micrometer. Between 2 and 20 micrometer. I hope you know that a micrometer is 1/1000 of a millimeter. So nanoplankton are between 2 and 20 micrometer. Then you have the picoplankton or the picoplankton, PICO, then planting. The picoplankton or the picoplankton is between 0.2 to 2 millimeter. So 0.2 to 2 micrometer. So these are classification based on the size. Then we also have the classification based on the life history. Now, here, please, I want us to listen also very carefully. Here we have two major types based on the life history. We have those ones that spend their entire life as a planting, as a drifter. Their entire life. So their baby and their adult, or their child and their parent, are still planting. Okay, those ones are called holoplankton. But we have some of them also that spend only a lifespan, only a life stage. Okay, sorry, not lifespan, life stage. Only a stage of their life cycle as planting. For example, you see some fishes or some mollusks, and at a point they have eggs, okay, and the eggs will develop to larvae. Now that larvae can be planktonic, but just wait a minute. When the larvae grows into adult, it cannot be planktonic again. But at that stage of being the larvae, it was planktonic. So this type of planting are called meroplankton. This type of planting are called marrow planting. I repeat, planting for those that spend their entire life cycle as in the planktonic stage or as plankton, and marrow planting the one that spend only part of their lives in the plankton. Alright, so these are the definitions, these are the classifications based on life's history. Okay, now having talked about this marrow planting, let's discuss a little bit about it. Now, these marrow planting are mostly larvae of higher organisms. They are mostly larvae of higher organisms. And as you know, I'm a benthic ecologist. Most of the benthos have their larvae as planting. Okay, and that's why we want to talk a little about the larval type and strategies. Larval type and strategies. Now, even in this larval stage or this larval planktonic life stage, there are three types. That the one we call the plantotrophic larvae. The plantotrophic larvae, they feed on plankton. Remember, we are talking about the marrow planting now. Okay, and this marrow planting, we say that they spend an aspect of their life, a stage in their life cycle in the planting. Okay, now, so they are likely to be zooplanters, very likely to be zooplanting. So we have the plantotrophic larvae. This plantotrophic larvae will eat or do eat planting. That's why it's called plantotrophic. They do eat plankton. Plankton, trophic, feeding on plankton. All right. So what are their characteristics? Number one is that they have little or no yolk, so they have to scout for their own food. Okay, so they feed while they are swimming, okay, moving about, swimming, looking for food. Now, they normally, animals that have this type of larvae normally produce a lot of eggs. A lot of eggs, because some of those eggs will, some of the larvae will not survive while looking for food. They expose themselves to the predators and they got eaten up. So as a survival strategy, a lot of them has to be brought in. That reminds me of what happens in the olden days. I was asking, why is it that our forefathers have a lot of children? And the answer was simple. It's because not a lot of them, not all of them will survive. Okay? Not all of them will survive. Then there was no medical care. So a lot of diseases can come and erase a lot of people. So a lot of them will not. That's why you see somebody that had up to 12 children, but he only about 3 or 4 or 5 remaining. So because they know that some will not actually survive, they have to they have to bring forth as many as possible so that some will survive, and some will not survive. So by the time they remove those that couldn't survive, they still have a little to live with. So for this plantotrophic larvae, they produce a lot of eggs that will get a lot of larvae, knowing fully well that some of them will not survive. Many of them will not survive. And then they will now fall back to some of them that actually survive at the end of it. So what are the advantages? The advantages of plantotrophic larvae. Number one is that they have a large number of young ones are produced for a given amount of energy. So they don't actually spend a lot of energy producing. Okay, they produce as many as possible with little or no investment, on each offspring. So number two, that they are also widespread. That's wide dispersal. Wide dispersal because they are pelagic. They are pelagic larvae, and they don't disperse very fast. Moving away from the parent, trying to look for food, and dispersing to new environment in doing so. Now, what are the disadvantages? Disadvantages are: number one, larvae will depend on planting for food, and this is unreliable. So there's unreliable source of food, okay, unpredictable source of food. All right. Number two is that uh they stay long in the planktonic stage. Okay, they stay long because there's no enough food to get them to develop and then move to the next stage. And because they also move about looking for food, the chances that they got eaten by predators, and then mortality is very high because a lot of them will get eaten. All right, so these are some of the disadvantages. Now let's get to the next one, the lecitotrophic larvae. The lecitotrophic larvae are the ones that actually get supplied with egg yolk. They get supplied with yolky oocytes. Yolky oocyte. Okay. So what happened that the parents, when they release them, they supply them with food. And because they supply them with this food, they don't need to be moving up and down looking for food. Okay. And then they minimize the rate of being eaten up or being killed by the predator. So they always have fewer energy rich eggs. Larvae do not fit while swimming because they have food supply. So, and they now have less settling time. Metamorphosis is very fast because they have food, so they develop fast. The metamorphosis is fast, and they get to the adult stage fast. Now, what are the advantages? The advantage is that they spend less time in planktonic stage, and then there's less time of being exposed, to predators, and then they don't depend on unpredictability of the food supply. And what it means that they have food supply for them given to them by their parents at birth. So they were born, as it were, with a silver spoon with food supply from the onset. So they don't go about looking for food. So they don't starve, they don't get killed. All right. So, but what are some of the disadvantages? Remember, please, if you there's any point you don't get, pause and re-listen to the audio, please. Now, what are some of the disadvantages? There are few eggs, and then which will eventually develop to fewer larvae, or there's less dispersal, and then there's what they call the short time. No, there's less dispersal because they have shorter time in planting, and then because they carry a lot of food, they become target for predators. They become target for predators. My people used to say something that is somebody that carries the meat, that is in possession of the meat that the dog will go after. Okay. What it means is for because they have yolky oocytes, qualitative food with them, they are target. So that if a predator can just get one of them, is okay for almost a week. So they are target. All right. So the next one, the last one, is the one we call the non-pelagic or direct development. These ones are not pelagic. Okay, they develop directly from the parents. Okay, so there's no larva, there's no pelagic. They might be larva, but they are not pelagic, so they are not exposed. Okay, and then adult produce few eggs, not each with a very large amount of yolk. Okay, That's the non-pelagic one. Okay, that's long development without additional energy source. Okay, and then very few of them, no, there's no swimming, there's no free swimming lava, and then uh, the mortality rate is almost zero. Now, the mortality rate is almost zero, and then the parents can just have one or two of them. So let's see how we can apply this to real life. You see, these rich men, they have very few children, one or two. But you see a poor man having so many children. Now, that one that a rich man has will have everything he needs in life. Okay, we have everything. He doesn't need to go and look for a job. In fact, he doesn't even need to trek to school. The driver will pick him to school, bring him back. He has everything he needs in life. Okay, but there are still some disadvantages to that. But the advantage to this one now is that they don't actually they are not exposed to predators. Mortality rate is almost zero because there's not planktonic stage. They don't starve. The parents supply them with everything they need. Now, but what are the disadvantages? Only a few eggs can be produced by available energy. So they impute a lot of energy on one person. They put all their resources in one person. As it were, they put all their eggs in one basket. Now, if something should happen to that basket, what happens? All the eggs, all the investments, all the life earnings, all the life investment is destroyed. So, disadvantage here is that they put all the energy in one resource, okay? And if there's a natural disaster, if there's something that just happened abruptly, and then the only one got destroyed, it means that the generation has ended. The serious matter. Then there's also no dispersal, and they know the importance of dispersal. Dispersal leads to viability. Okay, it reduces overcrowding and all the rest. But here there's no dispersal, so these are part of the disadvantages. Please, my dear postgraduate students, please go and read more and get more information. All right. Now that's no what we just discussed is actually about the marrow planting, because at the larva stage. By the time they move on from the larva stage, they are no longer they are no longer planting. Okay, they are no longer planktonic. So let's discuss the ray planting, the hollow planting. Now, this hollow planting, many of them are phytoplanting. Phytoplanting. Almost all the phytoplanting are hollow planting because in all their lifestyle, all their life cycle, they are planktonic. We also have the cyanobacteria. But before that, the phytoplankton, of course, you know that they are photosynthetic. Okay, they have chlorophyll. Okay, chlorophyll A. Chlorophyll is a common. Chlorophyll A is common to all of them. Okay, they can be unicellular, a single cell. They can also be in colonies. Uh, Normally, they are small in size and they have rapid reproduction. Growth can be slow, and then they can grow rapidly actually, and then maybe form a bloom. You have heard of a bloom. A bloom is where you have this phytoplankton growing rapidly and then congregating, forming colonies, colonizing the water body and then giving it their own type of coloration. All right. So now the next one is the cyanobacteria. Cyanobacteria are the blue green algae. Now they are prokaryotes. Cyanobacteria are prokaryotes. What do you mean? What do we mean by prokaryote? Prokaryote is gotten from two words. Pro meaning before and karyote meaning or karyon meaning shell. So the prokaryotes are those organisms that have not evolved cell membrane. So they don't have cell membrane. Their nuclear material are naked. Their DNA and their RNA are naked. They don't have nuclear membrane that cover them. So they are called prokaryotes. Prokaryotes. Any other organism that has nuclear membrane are called the eukaryotes. Eu mean true, true carrion, true shell, true coverage. All right. So, but the prokaryotes are those ones that don't have the cell membrane, pro or before the carrion or shell. Now, there's something important we need to know about the cyanobacteria. The first one is that they have, apart from the chlorophyll, they have some other pigments like the phycocyanin, 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 spelled Phycocyanin, phycocyanin. Okay, phycocyanin is blue in color, is a blue pigment. Then they have the phycoerythrin, phycoerythrin, erythrin, erythrin, phycoerythrin. Phycoerythrin is a red pigment. So that's why they are called blue-green algae. They have red pigment phycoerythrin, or they also have the blue pigment phycocyanin. They are abundant in the tropics. They are abundant in the tropics and less abundant in the temperate or cool region. Okay. Now, you would have heard of the Red Sea. Okay, the Red Sea is just because you have a lot of the cyanobacteria with the coloration on the phycoerythrin, giving it a red color. Okay, a red color. That particular cyanobacteria is called, or that particular cyanobacterium is called Trichodesmium. Trichodesmium erythraceum. Trichodesmium erythraceum. Let me spell it, sorry, it's not an English word. Trichodesmium, Trichodesmium, Trichodesmium. Erythraeum, from the word red. Erythraeum, erythraeum. That is the particular cyanobacterium that gives the Red Sea the red coloration that makes us to call it the Red Sea. Now, something else we need to know about the cyanobacteria, remember we said that they are holoplankton, is that some of them are nitrogen fixers, what we call the nitrogen fixing bacteria. The nitrogen fixer, they fix the atmospheric nitrogen, okay, into usable forms like the nitrate. So they are the nitrogen fixers. All right, so the next one is the dinoflagellates. Dinoflagellates. The dinoflagellates they have flagellum. They are flagellated. They are flagellated. They have two unequal flagella. They have two unequal flagella. Okay. Some of them produce toxins. Okay. Some of them produce toxins. And they are responsible for what we call the red tides. The red tides. The red tides. That's reddish toxin that is actually toxic. You know. So we have some of the toxins are the saxitoxin. Okay, saxitoxin is called the PSP, paralytic shellfish poisoning. It causes paralytic shellfish poisoning, PSP, the saxitoxin. You also have the brevitoxin that is responsible for the neurotoxic shellfish poisoning, the NSP, neurotoxic shellfish poison, NSP. Then you have the ocadaic acid, you have the ciguatoxin, which causes this ciguatera fish poisoning, and so on and so forth. Some of them also bioluminesce. In other words, they give light. Okay, they give luminance to the water. All right. So then we have the haptophytes. The haptophytes are the coccolithophores. Then we have the prochlorophytes. Prochlorophytes are primitive bacteria. Okay. They are most numerically abundant phytoplanktons in the open ocean. Then we have also the zooplankton. Some zooplankton actually are holoplankton. Not all zooplankton that are marrow. Some zooplankton also spend their entire life as plankton. You would have heard of the copepods. Copepods are arthropods, from the class Crustacea. Throughout their life, they are they are they are actually planktonic. You also have the forams, the foraminifera. They are also planktonic. They are zooplankton. You have the radiolarians. We have the cnidarians. You have the ctenophores, and then of course we have some polychaetes. Some polychaetes are purely holoplankton. That is, from the beginning to the end of their life, they are planktonic. All right. Now let's conclude this lecture with this plankton flotation mechanism, and we are going to talk about the stroke law. The stroke law, of course, is a physical thing. It has to do with physical oceanography, or physics as it were, but science is intertwined. So we need to see how stroke law is applied in the flotation of plankton, because we say that plankton actually are drifters. They float. So they apply the stroke law to be able to float. Now, what is stroke law? Stroke law says that the frictional drag F is directly proportional to the weight of the sphere. Okay? In other words, that F is proportional to R cubed. Okay? So you don't need to memorize the equation. Now, the force acting downwards is equal to the force acting downwards is equal to 4/3 pi R cubed, bracket open, D1 minus D2, bracket close, times G. Okay? In which case, D1 is the density of the sphere, D2 is the density of the liquid, and G is the gravitational constant. Now we know what pi is. Pi is 22/7, and R is the radius of the sphere. All right. Now the density of water will change with temperature. Of course, we know that the density of water will change with temperature and salinity, and it will now affect the sinking rate. Okay. Now objects of different types but similar mass will fall at different rates. Okay. So more surface area leads to more resistance and then slower sinking. Now we can summarize it with this equation. SR equals to W1 minus W2 over R times V. Now, where SR is the sinking rate, where W1 is the density of the organism, W2 is the density of the water, then R is the surface of resistance, and then VW is the viscosity of water. Well, I know that some of us are have phobia for mathematics, but then it is good that you know a little of everything because you are a scientist. So, in what we are saying that we apply or Stokes law, we apply the Stokes law to assess the rate of sinking or the rate of floating of any plankton. All right, so this is where we are going to stop for this class. And just as I said earlier, is going to be the last class. This is the sixth video, right? Yeah, and the fifth lecture. So please, very soon we are going to have a text, and then that text, I bet you won't cheat. Even like has gone far, you won't be able to cheat. It will still be virtual, maybe with Zoom, and then with some software that we need to install to be able to do that. Thank you so much. Thank you so much. I still have about two other courses to take with you. But if you have any question, go to LMS, drop your question. If you cannot access it, you can give me a, do I say private message? I don't want it to be abused. Go to LMS, you will get it. Go to LMS. Uh, that's a place for you to actually put in your question, put in the question, and you will get the appropriate response. Thank you so much, and be good.